Hello everyone. Few students are having one doubt regarding the value of these forces. How to take this value as 0, I will explain now. I am talking about 4-bar mechanism which is subjected to 3 forces. F2 is acting on link 2, F3 is acting on link 3 and F4 is acting on link 4. F4 on link 4. These are the applied forces which are acting on these 3 different links. First we have to consider any one of the force and we have to neglect other 2 forces. In case 1, I am considering only F2 and I am neglecting these 2 forces. Okay. Now when I neglect these 2 forces and when I consider only F2, I have to draw the free body diagram of each of these links. You know that one very well, how to draw the free body diagram. Here first you identify the member which is subjected to 2 forces. Okay. Now link 3 is a member which is subjected to 2 forces. Link 2 is exerting force on link 3, that is called as F23, and its direction is towards link 3. I am assuming its direction is towards link 3 initially. Okay. According to conditions of equilibrium, we know that the other force acting on this link on other end is equal in magnitude and opposite in direction. Which is the other force? So link 3 is getting another force from link 4, F43. I am assuming the direction of F43 is towards this link 3 itself. According to conditions of equilibrium of 2 force member, the forces are collinear to each other, equal in magnitude, opposite in direction. Okay. So which is the another link which is subjected to 2 forces? Link 4 is the another link which is subjected to 2 forces. When there are only 2 forces, we know that the forces are collinear to each other. Hence, the force from fixed member is acting along this link 4 itself. But actually what we will do in other problems, we will represent that force from fixed member like this, which is unpredictable. So, this is unpredictable when there are more than 2 forces. When there are more than 2 forces acting on the particular link, then force from fixed member is unpredictable. The direction of force from fixed member is always unpredictable when there are more than 2 forces. And also here one torque is also there. So in this case we can't predict the direction of force from fixed member. But for a 2 force member, we know that conditions of equilibrium, we can easily show the direction of force from fixed member. In order to satisfy the condition of equilibrium, it has to pass through this link itself. Therefore, this is F14. Another force acting on this link 4 is F34. F34 is opposite to F14 and it is equal in magnitude. Okay, so this is the direction of F34. Now, I have shown the direction of this link forces acting on link 3 and also forces acting on link 4. I explained that one now. Now we know that the force convention we know that one very well. Fij will be equal to Fji. That means F43, the force F43 is equal to F34. Their magnitudes are equal but they are opposite in direction. This is the direction of F34. So therefore F34, this is F43, this is the direction of F43. F34 should be opposite to this F43. Okay, so hence I am showing that one like this. This is F34, but this is according to force convention. This is according to force convention. We have to represent F34 in this direction, towards right direction. But to satisfy the condition of equilibrium, F34 should pass through this link 4 itself. It should be collinear to link 4. To satisfy condition of equilibrium, the forces are collinear. Hence, we have to change this direction. We are changing this direction like this. According to force convention, this is the direction of F34. But to satisfy condition of equilibrium, I am changing this direction of F34. In order to change this direction, we have to assume that force as 0. Whenever it is required to change the direction, we have to assume that force as 0. Why we are changing that dimension means in order to satisfy conditions of equilibrium of two force member. To change that, we are assuming that value as 0. That means it doesn't has any effect on link 4 when we change that value as 0, when we assume that value as 0. Okay, when F34 is 0, this is two force member. The forces are equal in magnitude and opposite in direction. When F34 is 0, so what about F14? This is also equal to 0 because they are equal in magnitude in two force member. Similarly, when F34 is 0, here F34 is equal to F43. Hence, I am assuming F43 as 0. They are equal in magnitude. Okay, when F43 is 0, this is also a two force member. These two forces are equal in magnitude. When F43 is 0, F23 is also 0. According to sign convention, according to this force convention, see here, Fij is equal to Fji. Therefore, F23 is equal to F32. When F23 is 0, F32 is also equal to 0 according to force convention. Okay, F23 is 0 and hence F32 is also 0. But the direction of F32 should be opposite to that of F23. See here, this is the direction of F23 and hence F32 should be opposite to this, like this. Okay, so now this value is 0, this value is also equal to 0. When this value is 0, so which are the forces acting on link 2? There are only two forces. First force is F2 and another force is F12. Initially we are assuming that this force is unpredictable because there are more than two forces. Now when we consider this force as 0, when F32 becomes 0, which is not having any effect on link 2, now there are only two forces and one torque. Okay, the condition of equilibrium of a link subjected to two forces and one torque. What are those conditions of equilibrium? Please try to recall. The forces are opposite in direction, equal in magnitude and parallel to each other. That means when there is a torque and when there is a, so this is torque. When there is a torque and when there are two forces, these two forces are parallel to each other, opposite in direction and equal in magnitude. So this is the direction of F2 and hence now this is the direction of F12 because these these are the only two forces acting on link 2 which is subjected to torque. Okay, to satisfy condition of equilibrium, these two forces are parallel to each other. Hence, you draw a line which is parallel to this, and these forces are opposite in direction. F2, this is the direction of F2, and hence this is the direction of another force. Okay, and rest of the things you know very well. You have to draw this H2A line, and you have to get the torque in case 1. When we consider only F2, what is the torque? That you have to find. Similarly, you have to find the torque values by considering F3 in case 2. And in case 3, you neglect F3 and F2 and you consider only F4, that is case 4. Again, you find the torque acting on link 2. Okay, in each of these cases, you find the torque, and summation of all these torques which are obtained in 3 cases, that gives the total torque. I hope now you got it. Thank you.